All right. Good morning to you guys. I hope you guys are doing well. Okay, we got some work to do today. Okay, some pretty good work. We're going to warm up today with the S portion of the course. Remember, we could do it at any time, but I want you guys to warm up here with some algebra, okay? Because we're going to use this algebra for this next section. This is very important. So we're going to warm up with some algebra, okay? So I want to share with you guys what I want you guys to warm up with. We're going to solve trig equations. This is what we're going to start to do. But the big thing to do first is try to use some what? Algebra. Try to review, okay? So we're going to review algebra for the S portion this morning. And let's see how this goes, okay? I'm going to give you guys some time to warm up and wake up. And let's try these out, okay? All right. All right, ladies and gentlemen. Okay, let's handle the S portion of the course. Okay, so if you guys haven't figured this out, this is actually, some of these questions are like pre-algebra and algebra 1-ish questions about how to solve equations here. Okay, and I think it ranges from pre-algebra, I would say, all the way up to intermediate algebra. Okay, and I'm going to show you what I mean by that. Okay, so what do you guys do here when you solve for x? Do you guys remember? Right. For the first one, you're trying to undo the addition of 2. Is that right? So you're going to subtract 2. That's the only way you can undo addition of 2. It's like subtraction is the opposite operation of addition, because if you said, what happens here with this what? You got to do some arithmetic. Is that right? $2 minus $2 means you're broke. That's 0. It's gone, right? And then you say, what about the other side? What's 1 minus 2? Do you guys know? 1 minus 2 is what? -1. Good. So you actually solve for x here. Okay? There's your solution. All right, pretty good. Okay, did you guys get -1? Hopefully. Now, what about over here? You say, I got my what? Subtraction of 3. How do I undo subtraction? Right, addition and subtraction are opposite operations. So, again, -3 plus 3 gives you that nice 0. But on the other side, you got 4 plus 3, and what does that give you? That gives you 7, and ladies and gentlemen, you solve for x. There you go. There's your solution. This is all, warm up from beginning or pre-algebra, these kind of questions, okay? And again, these are kind of pre-algebra-ish questions as well. So, okay. How do you undo? If I said to you guys, I think I already put the answer, but what's happening between the 2 and the x? Do you guys remember? It's multiplication. So how do you undo multiplication? You can divide both sides by what? By 2 and get this cancellation. Is that right? And so you get now x going to be on the left side. You did your cancellation here. And what's -6 divided by 2? What's that going to be? It's -3. So ladies and gentlemen, you have now what? A solution being -3 here. All right, you guys okay? You guys okay with that? You guys remember these kind of things? Now, what about this here? You say, isn't this the same as number 3, where you have to divide both sides by the number doing the multiplying, and in this case, the number is what? -3, is that right? And then you say, what do I have? Well, you have what? X being, what's 12 divided by -3? It's -4. And there you go. All right. Now, this is what I call here a two-step question. Okay? This is when I used to teach those beginning algebra courses, or even in pre-algebra, this is a two-stepper. Do you guys know why we call that one a two-stepper? Because there's 2 operations to undo, right? You have the subtraction of 1. You guys know what's the opposite operation? Yep, you got to add 1 to both sides here. So you get the 3x, and then 8 plus 1 is 9. So you're working with this left side and the right side, right? Okay. Now, the second operation is that 3 being multiplied to x. You got to divide both sides by that 3. And so now you get x by itself, but you have to know what 9 divided by 3 is. What's 9 divided by 3? 3. And ladies and gentlemen, there you go. All right, you're done. All right, you guys remember some of that beginning algebra? All right, and then this is another beginning algebra or pre-algebra question. How do you undo, if you guys remember, this division of 2 now? Right? The opposite operation of division is multiplication. You say, what do I multiply by? The number doing the dividing here, that's 2. But because this is negative, you have to undo that negative as well. So you're going to multiply by negative 2. So negative 2 divided by this negative 2, if you said, I want to see a lot more detail there. Okay, all right. Let me go back, because this is where sometimes there'll be some questions, right? To give you an intermediate step, I'm going to look at it this way. I'm going to put the negative 2 on the bottom there. So I'm going to take this negative sign here and put it down there. So that when you say, do I have to multiply both sides by a negative 2? And you use a parenthesis to emphasize the number's negative, then you know, oh yes, you're dividing by a negative 2. Okay, so that's the intermediate step. And then remember, you have to recall arithmetic with signed numbers. 5 times negative 2 is negative what? Negative 10. And there you go. Now you got this x squared minus 1 is 0 here. Is that right? So you might say, this is different. Where do you first see some of these? You still see these in beginning algebra, but you also see them in intermediate algebra. And I'm going to suggest you guys recall the intermediate algebra. Here's what I'm saying, right? I'm going to add 1 to both sides here, and you end up with the x squared equals to 1. So you're undoing, again, subtraction of 1 here. Okay, and 0 plus 1 is 1. Now, here's the thing about it. Do you guys remember how to solve x squared as 1? What do you guys do from intermediate algebra? Yeah, you're going to use what's called the square root formula. Okay, now I have this information on my website. If you said, where can I see some more of these things? Well, intermediate algebra has some videos here. That's Math 125. It's called the square root formula. Okay, and of course here next to it you have the video solutions, is what I'm talking about. But back to how to use this, let me write down, if you guys recall, the square root formula. Here's what I actually do in intermediate algebra. I give them this formula. If you have x squared equals n, this n I call simply a number. If you have that, then we can say x is plus or minus square root of n. Okay? So you do have to know a few things here. Number one, you have to know how to evaluate a what? Square root, and you got to know the meaning of plus or minus. This is what you guys use to solve for x. So at this point, you can say, does that mean x is going to be plus or minus square root of 1? Because why? Isn't 1's a number? This is where that 1 is. And what is the square root of 1, by the way? Yeah, it's 1. So you say x is plus or minus the number 1. Is that true? Now, what does that mean? It means x is positive 1, and it means x is what? Negative 1. There's your solutions. If you go back up here, what does it mean, right? We say we have to add 9 to both sides here. And then 0 plus 9 is 9. So you're doing the arithmetic again. Negative 9 plus 9 is 0. 0 plus 9 is 9. And then you have to use the square root formula again. Plus or minus square root of 9. Now, what's the square root of 9? Do you guys remember? That's 3. Okay, so again, you have two solutions. And it means x is positive 3 is one solution. X is negative 3 because of the meaning of this plus or minus. So I spent a lot of time in that class trying to convince students what the meaning of plus or minus actually is. It means two things. It means plus or minus. One case it's positive, the other case it's negative. So just to kind of remind you guys, this is kind of, again, how to review some algebra for solving some equations. And you might say, what about this, the last two? Well, here we can add x squared to both sides. And for the arithmetic, we get 16 is x squared, meaning negative x squared plus x squared is gone. 0 plus x squared is x squared. That also does mean that x squared is 16. So what does this actually mean as well? We can say what? That x will be plus or minus the square root of 16, which means x is plus or minus 4, okay? So we're using the square root formula here. Here's that 16, square root of 16, we know is 4. And you say again, plus or minus, meaning two things. X is positive 4, or x is negative 4. So there's two solutions here. All right, you guys okay with that? This is review of algebra, square root formula. Now, this is another very important kind of equation. This is still a quadratic, by the way. These are all quadratics. I shouldn't say all. The last 2 or 3 were quadratics. You say, how do I know? Highest power is what? 2. That makes it a quadratic. But it's a special quadratic. If you use FOIL but don't, you get another quadratic and you go, oh, these are solving quadratics. This is also from beginning algebra. But this is in a very nice form. You say, what form is this? Do you guys know what rule is called to solve this? Do you guys know? If you ever have a product, here's what I'm saying. One term times a second term, and it equals 0. What does that mean? If you ever multiply two things together and it equals what? 0, then what does that mean? Then it means the first thing was 0, or the what? Second thing is 0. And do you guys know what this is known as? This is another important fact. Anybody know the formal name of this? Remember, the product equals 0. That means either of those things was 0. This is known from beginning algebra as the what? The zero product what? Rule. Okay? Now you say, do you have these things on your beginning algebra page 2? And I'll say, yes, ladies and gentlemen. I believe it or not, I do have a beginning algebra page. See that? This is from the beginning algebra page. Oops. Here's the worksheets and videos. So the topic, though, from that page, there's a younger Mr. Judge, by the way. I used to do this stuff since I've been making videos since before Khan Academy, or about the same time or something. But that guy's probably a billionaire. Mr. Judge is not. Oh my God, amazing, huh? So here's what we call solving quadratics by factoring. Yeah. So it's kind of like right here. You got a video of this stuff here, just so you guys know. Anyway, and a worksheet there too. So something you guys can take a look if you like. But how do you use this? This is how we use it. I bring out the t. And I say this means x plus 3 has to be 0, or it means x minus 2 is 0. I'm using that 0. Set the first thing equal to 0. Set the second thing equal to 0. I am using the zero product rule over here, ladies and gentlemen. I'm using this here. So now I have two equations I can solve, right? What do? We do what? Subtract 3 from both sides, and we get what? X is 0 minus 3, which is negative 3. I add 2 to both sides here. I'll get x is positive 2. I don't like that being a dot. And there you go. Easy breezy lemon squeezy. All right, ladies and gentlemen, here we go. Okay. Now, if you said to me, what does this have to do with us today? Well, we're solving what kind of equations today? What do you guys know? We're solving what's called trig equations. So here's an example I'm going to start with. Okay, because I do even have videos here so you guys are aware. Let me kind of go here to this. Weird. Okay. We got trig videos. Let's go to the trig resources. All the way down here, developing those trig resources. This is right in here, trigonometric equations. So I have additional examples there. Okay. But this is also put up for calculus students because some of those calculus students forget how to solve trig equations. So I do have some resources for you guys here too. Anyway. So you might say, what are you gonna see here? They're gonna say solve for what? X. And then what you want to know, this isn't important. They're going to give you over a restricted domain. This is interval notation. Okay? So I want to remind you guys, what does this mean? Do you guys know if they have that interval? This means what? This means that the x value is between 0 and 2 pi. This is going to be an important detail. Okay? So this is a restricted domain situation. You'll see what I'm talking about. You say a restricted domain for what? For the cosine function. So that's a very big deal when you guys first start these. Because you're solving for x, you say, where's the letter x, right? Solve for x. X is right here. So in order to first solve for x, you know what you really have to do? Here's what you really have to do first. You have to solve for cosine of x. That's really the first thing you got to do. And you say, why did we warm up? Because you're going to undo the subtraction of 1 with the cosine in the same way you started earlier today. Okay? So what this gives you is just cosine on the left-hand side is 0 plus what? 1. Okay? Easy breezy, lemon squeezy so far so good. This is why you had the warm-up from algebra, or the S portion, the supplement portion of the course. I think it's probably a little helpful here. Okay? So that's how you start. You solve for cosine. You say, okay, great. And then now you say, well, what does this mean? We have to determine, what is x? What does x have to be to make cosine 1? Not just what does x have to be to make cosine 1, but under a what? A restricted domain situation. Okay. Now, here's what I want to remark. Do you guys remember we studied graphing? Didn't we study how to graph? Well, I just want to remind you guys that we never wasted our time. Because what I do personally, and I think what you guys want to do personally, is always remember this. Because you're going to see these courses in various science courses. See these questions. You always want to remember that first cycle of what? Of cosine. So this is all the little detail we work with for cosine. Remember, cosine starts at a maximum value and then goes to an x-intercept, and then goes down to a minimum value and goes to an x-intercept, and then goes to a maximum value. And we shared this. We worked on this stuff. Easy breezy, lemon squeezy? So when I was a student, I used to see all these questions all the time. And I go, oh my God, what does x have to be for cosine being 1? Well, they're talking about this value right here, aren't they? Right? They're talking about the x values, though. So what do you think x has to be? Right, x is 0, and x is 2 pi. Those are your solutions in the what? Restricted domain. You are what? Done. You're done, ladies and gentlemen. You're finding these x values down here. Okay? 2 pi. And you say, well, where's the 0? We don't write it down, but it's right here. You know, it's really right over here. Okay? So this is what this is what you guys want to remember in your mind, without a doubt, how to graph. And that's not a coincidence when they say 0 to 2 pi, because that's that one cycle of cosine, okay? You guys see what I'm saying? This is where you start. Easy breezy, lemon squeezy. This is your first trig equation. I'm going to say this. Note, they could have given you cosine plus 1 equals 0 over that same interval. Okay, we're going to focus on this interval today. And if they did, you said, do I have to subtract 1 from both sides and get cosine being what? Negative 1? And the answer is yes. Okay, you guys with me on this one? This is a different question. They want to know now, what is x? So you might say to me, what do I do here? What do you guys think we do? Go back again to the what? Cosine curve. This time, what are you guys looking for this time? This was the solution. I'm going to remove these here so you guys don't get confused. This is a solution for cosine being positive 1. What about cosine being negative 1? Where's negative 1 at? And over here? What's the value of x in that restricted domain? Remember, this is the domain they restricted. So what would you say x has to be in this case? X is what? Pi, ladies and gentlemen. And there you go. Easy breezy, lemon squeezy. All right. Good job. Good job. Okay. And let me give you guys another example. What if they said, okay, what if they give you 2 cosine x minus 1 equals 0 then? This is a different example, and we're going to use the restricted domain today. You might say, do I still solve for cosine first? I say yes. So you have what? Let's solve for cosine. How do you do that? You add 1. Is that true? You get 2 cosine x is positive 1. And then what do you guys do? Since we're trying to solve for cosine, divide both sides by that 2 here. Okay? And then what do you have here? You have what? Cosine x is positive what? 1/2. Right? And then you say, well, Mr. Judge, do I go back to this curve and find where cosine is 1/2? And I'll say, well, 1/2 is right here. Is that right? And if you guys want to know, guess what? Over that interval from 0 to 2 pi, there's actually 2 solutions. But you don't know what they are. All right. Okay. So then the question is this. What do we do? We got to find where cosine is 1/2. Anybody did the homework on the inverse trig functions? What do we know about this? Do you guys know what I'm talking about? We can deduce where cosine is 1/2. We can do that. You say, what do you mean? Well, we got to find the angle x. This is just like the last section's homework. This is x. Remember, what is cosine here? Positive. What does that mean about x? We got to think about what quadrants x is going to be in. But remember, these are all specially chosen. So cosine is adjacent over hypotenuse. Is that true? Okay, you guys see what I'm saying? I'm going to say x is in what quadrants? So what is the opposite side if we have adjacent being 1 and hypotenuse 2? Do you guys remember? That's the square root of 3. So we know a little something here. Okay? What do we know? Remember, I'm going to get out my purple. We know cosine is positive in what quadrants? Yeah, where's cosine positive greater than 0? Where x is in certainly quadrant 1, the geometry, that's always the case. But what do you guys have to remember? Go back to something else we studied. You know what else we studied here, ladies and gentlemen? Yes. All students take what? Calculus. You guys remember this picture? One of them? So what I'm saying to you guys here is quadrant 1, all 3 trig functions are positive. Quadrant 4, what do we know about this C here? Cosine's positive. So we know x is in quadrant 1 and x is in quadrant what? 4. There's 2 what? Solutions. You see, there's no coincidence that this goes from 0 to 2 pi. No coincidence. So, okay, does anybody recognize this special triangle? You should. There's only 2. What special triangle is this? Do you guys remember? This is 1, this is 2. I think x is 60 degrees. Is that right? So you say, can I say 60 degrees? I'll say, well, put it in radian measure. Pi over 3. I'm going to express y. This is your quadrant 1 solution here, okay? So we should probably color this what? Purple. This is the quadrant 1 solution. But you also have another solution in quadrant what? 4. So do you guys remember how this works? It's the same way as what? I'm going to do it this way. Do you guys remember this is your what? Reference angle. Is that true? This is pi over 3, 60 degrees. So we need an angle, ladies and gentlemen, that's a positive angle. This angle is what we're looking for. Now, how do we get that quadrant 4 angle? Do you guys know? It's 2 pi minus the reference of pi over what? 3, minus the 60 degrees here. Okay, so this is how you get the quadrant 4 solution. Right? But you're not done because you have some arithmetic to do. So you might say, what's my arithmetic? Oh my God, we don't have to copy all that. I just wanted to copy what? Just wanted to copy this. Here's the arithmetic. See if maybe we can do it up here or move some things. Oh. I'm going to copy it. Do you guys remember by now? How do you actually do this arithmetic? You're going to have the same denominator, right? So you multiply the top by 3, the bottom by 3, and what do you end up with? You get 6 pi over 3 minus pi over 3. What does that mean? We get what? 5 pi over 3. There's the quadrant 4 solution. These are the solutions over your restricted domain. What was that restricted domain? 0 to what? 2 pi. This is code for saying solutions over all the quadrants, 1, 2, 3, and 4. Remember, because 0 to 2 pi goes through what? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's the meaning of it, and it's in radian measure. So these are kind of the real questions they're going to start to ask you. 2 cosine x minus 1 is 0. They could even say, by the way, or note here, just to kind of express this to you guys. They can say, what happens if it's 2 cosine x plus 1 is 0? That's very similar. You solve it the same way, subtracting 1, and you get what? 2 cosine x is what? Negative 1. You divide both sides by 2. And then you kind of right here, and you're saying, does this mean cosine is what? Negative 1/2? And I'll say yes. So the algebra we warmed up with today gets applied here. All right, you guys okay with that? Now, the question is again, what is x? And you want to remember something here, okay? Just like the last section, cosine's negative. So x lives where? I'm going to bring in a different all students take calculus picture. There we go. So if cosine's negative, what do you guys remember about this? What do you have to do? Where's cosine negative? It's in quadrant what? Quadrant 2 and quadrant 3. Because all students take calculus. Remember, 0 to 2 pi. 0 to 2 pi, that restricted domain is saying just consider, x being from 0 to 2 pi. They're actually thinking again of all 4 quadrants. This is why you start with this starting point. Now, what's the process? You guys remember the process? You got to go to the reference angle. You got to always go to the quadrant 1 what angle? Go to where cosine's positive. And you say, we just did that. We know it's 60 degrees. Do you guys remember that? See last example? But now this is a reference angle. It's a 60-degree angle. This is how you start this whole process. It's a quadrant 1 angle. The solutions are not in quadrant 1. It's in quadrant 2 and 3. So how do we use this to solve for x? Because cosine's negative. Why is cosine negative in quadrant 2? What does the S stand for? Sine's positive. That means cosine's negative. What does the T stand for? Tangent. That means cosine's negative. You guys with me on this? Just to kind of remind you, just in case you guys forgot, the solutions are in quadrant 2 and quadrant 3. So what do you think we'd have to do here? Do you guys know? How do you find quadrant 2 angles? Remember this. The quadrant 2 angle is this angle. So your reference angle, this pi over 3 is right in here. So for quadrant 2, that means x will be pi minus what? Pi over 3, right? Because you go, isn't this where pi would be? Yes, but you have to back up to what? So pi is here, and subtract the pi over 3. Oh, I like that. Pi is here, so it's pi minus what? So you say, here's how we start. You rotate all the way to what? Pi, and you got to back up pi over 3. And the algebra, or the arithmetic, is you put 3 over 3, right? And what does that give you? What's 3 pi minus pi? It's now 2 pi over 3. And there's your, we put a little subscript 1 because there's your first solution in a 2-solution setting, ladies and gentlemen. Now, how do we get the quadrant 3 solution? Remember what you do? We're gonna rotate. Where's the quadrant 3 solution? Well, it's right in here. But don't forget, the reason you need a reference angle is because this is the reference angle, pi over 3. So you start, and you rotate what? You got to rotate all the way over here. But this is how you look at it. You say, okay, I'm going to rotate what? Pi. And then I add pi over 3. Okay, let me do it again. You rotate pi. There we go. Stop. And add what? Pi over 3. There you are. So for a quadrant 3 solution, the second solution will be rotate pi, and now you add the reference of pi over 3. So this is why you care about getting that reference. The arithmetic says 3 pi over 3. So what's your second solution going to be? 4 pi over 3, and you are done. So there you go, ladies and gentlemen. There's your what? Second solution. Easy breezy, lemon squeezy. Sine x, square root of 3. Sorry, I'm going to put something here. 2. This is 2 minus what? Square root of 3 equals 0. And of course, it's going to be over quadrant 1, 2, and 3. So they can give you like an interval, or they can just say x is between 0 and 2 pi. They're restricting the domain for sine, okay? So as you guys know, you're going to have to do what? Add square root of 3 to both sides first. And you get 2 sine x equals square root of 3. Now, what do you guys do? You divide both sides by 2, is that right? And what happens now? You get what? Sine x is the square root of 3 over what? Over 2. What do you do with this? Well, where's your solutions, by the way? Right? All students take calculus, right? So if I were you, I would just write this all students take calculus down. I get to bring in the picture. Come on. Let's make it bigger so people can see it, right? So you say sine is positive now. Which quadrants? 1, 2. So you have a solution here and a solution here. But you do need the what? You do need the reference angle. The reference angle here is the same angle that we have for sine x. So, I mean, do your definition. I can do it purple, I guess. Use your definition. Okay, I can call that, since the solution is in quadrant 1, I could call that x. Okay, so we're talking about that quadrant 1 solution. What's the definition of sine? It is opposite, you're right, over what? Hypotenuse. So that makes this side 1. Is that true? Do you recognize this special triangle, by the way? Oh, x is again what? 60 degrees. And that's pi over what? 3. There you go. So this is this angle here. That's our solution. That's one of our solutions. So you could color it purple. You could color it blue. I don't know. Both. But that's the quadrant 1 answer. Easy breezy, lemon squeezy. How do we get quadrant 2 then? Right? Remember this. This has to be also what? Pi over 3. So, you say, how do we get that answer? Well, you know what you do? You got to rotate what? Pi. And then back up pi over 3. Do that again. Rotate 1/2 a revolution. Rotate. Oops, ran out of space there. So you rotate. Oops, not going to let me. Come on. Excuse me. Let me do that again. Let me get rid of that. It doesn't like it. Cut that. Gonna get rid of you. Here's what you do. You rotate pi, and then you back up what? That pi over 3 here. Okay? Do your arithmetic. What do? 3 over 3. So what's this answer going to be? It's 2 pi over 3. Now, this is the second solution. Here's your first solution. And ladies and gentlemen, there you go. That's over the interval of 0 to 2 pi. There it is. And this is how you answer those questions here. Okay, you guys okay with that? See, we got another example here. So what if they gave me 2 cosine x plus the square root of 3 equals 0 here on this one? Yeah, I just changed the function. And I changed the sign here. It's still going to be over 0 to 2 pi, okay? This is how I start these questions here. Your book doesn't, but I do. I think it's easier to do it this way. And do the algebra. You say, okay, I'm going to subtract the square root of 3 from both sides. Is that right? And you get what? 2 cosine minus square root of 3. Divide both sides by 2, and you get what? Yeah, you get cosine here. Negative square root of 3 over 2. Easy breezy lemon squeezy. All right, now you say, well, what do I do with this? Well, cosine's negative. You got to know where your solutions live. All students take calculus. So what quadrants does this in? Where's cosine negative? Right? So you get, oh, that's quadrant 2 and quadrant what? 3. So remember, the process always starts by finding that quadrant 1 positive solution here. Quadrant 1 here. And then you use your definition for a right triangle. You go, okay, this is a reference angle. Adjacent, square root of 3. Hypotenuse, this makes this 1. So what does that mean about your special triangle? What is my special triangle going to be? It is 30 degrees. We put this in radian measure, pi over 6. So this is not my solution. It's the solution for the reference angle. This reference angle here is pi over 6. Right? 30 degrees. Pi over 6. You always need that quadrant 1 reference angle. So if it's negative, you got to find it. Now, you say, well, how do we use this? We know our solutions are both the quadrant what? 2 and quadrant 3. So this here is going to be pi over 6. This here is going to be pi over 6, right? So we're going to start by what? Rotating what? Pi, and then back up pi over 6. Okay? And so this quadrant 2 solution, we're going to get x going to be pi, now back up pi over 6, This is why you care about that reference. And then over here, what is x going to be? Pi now what? Plus pi over 6. You add the reference. Now I'll try it again. Right? You rotate, if I can do that, if it lets me. Rotate pi, and then add a pi over 6. Here you rotated pi, and you subtracted the pi over 6. So this is, again, you know, how you go about getting your answer. Now, the denominator is 6, so what do we do? Multiply this top by 6, divide by 6. Top by 6, divide by 6. This denominator is 6. We're adding fractions with a whole number or subtracting. So 6 pi minus 1 pi, what's our first solution? X1 is 5 pi over 6. What's the second solution? 6 pi plus 1 pi is 7 pi over 6. Okay, and there you go. Here's your two solutions. There it is. There. A lot of art. A lot of art. What if they give you tangent minus 1 is 0? Right? Tangent. You're going to do some what? You're going to add 1 to both sides, and what do you get? Tangent is 1, because 0 plus 1 is 1. Is that right? Now, what do you guys know about this? All students take calculus. What quadrant is your solutions going to be in? Let's look. Where's my all? There we go. And yes, it's from 0 to, restricted domain again. Okay. So where is tangent positive? Quadrant 1 and quadrant 3. Is that right? Because that's what this actually means. Tangent's positive here. Tangent's positive in, because all means sine, cosine, tangent. But then how do we find the angle, right? We know what? Quadrant 1 answer and quadrant what? So how do we get this positive, reference? Right, 1 over 1. You guys know what I'm saying? I'm going to have to move this now again. This way. Okay. So you can say I got to find that quadrant 1 solution. And I got to draw a right triangle. Now, maybe I could draw the triangle purple because it's quadrant 1. There's my angle. Opposite and adjacent are 1. Is that true? Do you guys recognize this triangle by any chance? What's the hypotenuse? Square root of 2? What does that mean about x? X has to be what? 45 degrees, because this is the 45, 45, 90 degree special triangle. Only 2 special triangles I had to memorize the whole course. Radian measure. Pi over what? 4. So this is going to be what? My first solution, pi over 4. And again, but that's also the reference angle. Now, why is that important to know? Because this is also what? Pi over 4. This is also a reference angle. So my first solution, x1 is pi over 4. I need the second solution now. Right? And how do we get that second solution? It's a quadrant 3 solution. Remember what we do? We what? Rotate pi, and then you what? Add pi over 4. That's how you do for quadrant 3. It's pi always plus the reference for quadrant 3. So, okay. Since the denominator here is 4, you have to put 4 over 4. Is that true? Right? And then what's 4? 4 plus 1. Isn't that going to be what? It's 5 pi over 4. Yeah. What do you mean? Normally we get negative pi over 2. No, it's like 0 to 2 pi. Well, that's a very good question you have. The question's a very good question. Notice that this is really not, I should say, you're not using inverse tangent, are you? So inverse tangent, your question applies only for an inverse tangent solution, where you threw quadrants out. You had to make tangent 1 to 1. This is not that kind of question. Okay? Because what are they saying? This is, again, going to be over that original restricted domain from what? 0 to what? 2 pi. This is the restricted domain. Now, the truth is, they can restrict your domain any way they want. They can even say restricted from 0 to pi, in theory. They can say from negative pi over 2 to positive pi over 2, in theory. Or from negative 2 pi to 0. So, in theory, they can restrict your domain any way they like. And in that case, you find the coterminal angles. You know. But notice we're not using inverse tangent, inverse sine, inverse cosine for these here this morning at all. Now, can you do it? For some, yes, some later. But what I'm first teaching you guys here is essentially this. How do you solve equations that look like this? Tangent 1. You know, cosine, negative square root of 3 over 2. You know. Sine, positive square root of 3 over 2. You know. Cosine, negative 1/2. You know. So that's kind of how you start. And this is what I call by definition, cosine positive. So this is kind of how I start the whole lecture. Here's cosine negative 1. But you're going to see a lot of different variations. But it's important to start people with the algebra because you don't want them to worry about the algebra. But this trig portion you've seen already in 7.4 to some degree. Remember, all students take calculus, but you're not throwing out any quadrants unless they tell you. So, you know, I have this on my website. If you notice, I have this in, I call that single angle. Then I call this do some algebra, multiple angles, identities, you know, inverse trig solutions. So this is kind of a comprehensive deal here. You guys want to know? It's comprehensive. There's some work to do here in this section. So we just started that work. So what I'm going to do now here is I'm going to, you know, look at some of these questions I think you can try to do. You're not going to be able to do them all. All right, let's go over some of these equations here. We're going to solve more trig equations like we did yesterday, right? I promise you guys we do more. Also, to let you guys know, yesterday we went over a restricted domain from 0 to what? 2 pi for these questions, right? So that's a restricted domain. And today we're going to kind of integrate what we call the general solution, okay? So there's a way to look at these equations with a general solution, and we're going to try to do these here. So I put a list of questions earlier for myself to say, okay, let's try to get to these here examples here. All right. And I'm going to move these down, see what we can do. So you guys can see how to solve these equations, generally speaking. Okay, and let me see if I can move this further. Generally speaking, general solutions. Okay. So as you guys remember yesterday, you're going to have to solve for cotangent, right, using some algebra. So that's why we reviewed the algebra yesterday for the S portion. So now we're going to subtract 1. I'm going to say cotangent here is now -1, okay? All right, so you say, okay, cotangent is -1, but what does that mean? Remember, this is -1 over 1, so that means tangent will be 1 over -1. It's the reciprocal, so we take the reciprocal of cotangent, right, up and down, and we flip that over. And really what we're saying is that tangent is really -1 again. So we solved for tangent, okay? So we did solve for tangent like we indicated. All right, so we flip the fraction over because cotangent and tangent are reciprocals. Right? Remember that? If we say, what's the reciprocal? Well, we have A over B. B over A, they're reciprocals. Flip those fractions over. Now, tangent's negative. And so if you said, well, what do you know about that or what do you do here, right? Well, we're going to go back to the all students take calculus because that's going to help us obtain our answers. Because we have to remember, where is tangent actually negative? Do you guys remember? Tangent's negative where? Quadrant 2 and quadrant 4, okay? So your focus is on the reference angle being the quadrant 1 angle, and that's always a positive value. So this is our reference quadrant, quadrant 1, okay? Always, 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 quadrant 1 is that reference quadrant. Now, we have to write this as a fraction, and ideally speaking, again, we're going to have a special triangle, okay, for that reference angle. 1, 1, Pythagorean theorem says this is square root of 2. So that's the 45, 45, what? 90 degree. So sure enough, again, and we actually seen this yesterday, right? This is pi over 4. So this is going to be, very similar to what we seen yesterday because tangent here, remember, is positive 1. And the last example, I think, was tangent equals positive 1 here. So, we could have went back to yesterday's example. And, all right, now, here's the deal. The solutions for yesterday for the reference angle, well, here's how we're going to do this here. Here's how we're going to use it, right? Let's move all of this down. It's kind of the issue with creating problems way before you do them is you're going to have to, or writing them down, where you have to move this everywhere. All right. So what this means is simply this, okay? This reference angle is pi over 4. Our solutions are not in quadrant 1. They're in quadrant 2 and quadrant what? 4. So that reference angle goes here. That reference angle goes here. And now we have to deduce the quadrant 2 solution. That's going to be for x. And the quadrant 4 solution. Okay, you guys okay with that? So what is the quadrant 2 solution again? Remember this? I'm going to use a blue arrow today. So see if it does it. To get the quadrant 2, we have to rotate pi, and then we back up or subtract pi over 4. So it's pi minus the reference of pi over 4, ladies and gentlemen. And that's the first solution here. Okay, but you guys know you have to do some arithmetic. So you can only add fractions with the same denominator. So this means x1 will be 4 pi over 4 minus pi over 4 becomes what? 3 pi over 4. And this is your solution, okay, in quadrant 2. And then you say, but what about the quadrant 4 solution, the second solution, right? Well, what is this? Well, let's go back again and kind of use this blue arrow, right? Let's get the quadrant 4 solution now. You have to rotate one full revolution, which is how much? 2 pi, and then you back up pi over 4. Okay? So this will be 2 pi minus what? Pi over 4. So doing your arithmetic, multiply by 4 over 4. This gives us now what? 8 pi. That's right. So you say, is this 8 pi over 4 minus 1 pi over 4, which gives you, what's the second solution? 7 pi over 4. Okay? And so, ladies and gentlemen, this is how we solve the original equation for cotangent plus 1 equals 0 here. Okay, so these are your two solutions here. Okay, but be careful. I want to remind you guys here. These solutions are between 0 and what? 2 pi. So if they ever say to you, we want the solutions between 0 and 2 pi here. And sometimes they do. This would be your answers. Okay? And let me remark about this here. Okay? So I want you guys to know that this is when you have the restricted domain. Remember 0 to 2 pi? And those were the solutions that we did yesterday. Because when they say, you know, only from 0 to 2 pi, they're really referring to what you see right here. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, today, though, we're not going to focus on that. We're going to focus on what we call the what? The general solution. Right? We're going to do general solution today. So the general solution, ladies and gentlemen, is done differently. I should say it's done very similarly. That's the more accurate thing to say. It's similar. Now you might say, how and why is that similar? Well, what you're going to need to do now is this. Let me go back and erase everything. Yes, we need these solutions here. That's not the problem here. Okay? So I'm going to erase all that. Let's go back to the first solution. Here's my first solution here. When they say general solution, we know that first solution is what? 3 pi over 4. Is that true? Okay. What they mean by that is they want the family of solutions that goes on how? Forever. I rotated one revolution, which is 2 pi radians. I rotate another revolution, which is another 2 pi radians. I keep doing this forever. Remember, these are coterminal answers. So I can go in the other direction, subtract 2 pi radians, subtract another 2 pi radians. So I'm working with these revolutions, okay? So you might say to me, okay, then what do I do? Generally speaking, you add the revolutions. Do you guys remember the formula for the coterminal solutions here? What do? We say plus what? to n pi, not just 2 pi, but to what? N pi, okay? Now, do you guys remember what is n? N is a what? Integer. So this is the general solution that gives me all the other what? Co-terminal solutions. This is called the general solution. Okay, you guys okay with that? So that's my first general solution. I'm adding the multiple of 2n pi. This is where you have all those other what? These are the revolutions. The revs. Easy breezy lemon squeezy. Now you say, okay, what about the second one? Because we had two. You said, Mr. Judge, I have 7 pi over 4, right? We got these two particular solutions we're talking about. Right in here and right in here. So then what do you think the quick fix will be in general to do? Go back and what's really happening here, right? My second solution is right here. It's 7 pi over 4. Okay? But if I rotate one full revolution clockwise, that's an additional 2 pi. I do it again. I keep doing it all day long. I get all the coterminal solutions. If I go in the other direction, I subtract 2 pi. Another direction, another 2 pi, subtract. So how we actually get all the other solutions again is to add what? To n pi. What's n? N is an integer. What are integers? You might say, I forgot what integers are. Well, not in a trig course. We know what integers. Integers, ladies and gentlemen, and they're represented by a capital letter Z, by the way. It's this set of numbers. -2, -1, 0, 1, 2, and that goes on forever. So here's my integers, ladies and gentlemen. So this is known as what? The general solutions. Okay? You're looking at it right here. So I'm going to get rid of all this other stuff here. Okay, easy breezy, lemon squeezy. You simply add what? 2n pi to the end of the particular solution. You say, what's a particular solution? Solution in what? The restricted domain. So you took these particular solutions, and what did you really do? You added 2n pi to them. Okay? Easy breezy, lemon squeezy. All right. Okay, good. You say, wow, that wasn't too bad. I learned everything yesterday, so now that's good to go. All right. However, if you look in back of the book, you know what you're going to really see as the general solution? You're going to see 3 pi over 4 plus n pi. And still is a what? Integer. Okay? Now, I'm going to say to you guys, you say, Mr. Judge, which one would you want as a solution? I'd say whatever the book does. You go, what? But what happened? I don't get it. I thought you said all I have to add is 2n pi. Not necessarily. Yes, all you have to add is 2n pi. However, I want you guys to take a closer look at the solutions here. Okay? Did you guys notice something about this? You guys notice something about the particular solutions here? If I said to you, I got this first solution. All right? It's 3 pi over 4. You know what I can do to get the next solution? Here's the key. The key's right here. I don't know what color to use. Let's use green. All I have to rotate is another what? Pi radians. In fact, just rotate another pi radians. We get the next solution. Let's do this all day long. In fact, I can even go in the opposite direction. So the tip-off to me is always this. Here's the tip-off. if your solutions are in opposite quadrants, you know what you do? You use this version n pi. Only if the solutions are in opposite quadrants. Only. Like quadrant 2, quadrant 4, they're opposite. They differ by pi. If your solutions are quadrant 1, quadrant 3, they differ by pi. So only if solutions are in opposite quadrants, we can really get away with what? Just taking the first particular solution and add n pi. N is an integer. There you are, ladies and gentlemen. And there you go. We can now go across the street to Caro's or wherever and have pancakes for breakfast. That's it. Now, we have to see other examples so you guys get a little bit more comfortable. You guys know what I'm saying? Got to see some more of those so you get comfortable. But, hopefully you can get a lot of these in. Okay, so I wanted to kind of share that with you guys. Tangent and cotangent is where you're probably going to see that situation. Not necessarily for sine and cosine. Okay, notice here, we're going to have to solve for what again? This is the second example. Tangent. So what do? You add 1, and you get the square root of 3. Tangent is 1. Divide both sides by the square root of 3, right? And you get what? Tangent is 1 over the square root of 3. And yes, I'll need more space. Okay, you guys okay with that? Notice tangent is positive. So we're going to bring in our all students take calculus. Hopefully. So where is our solutions? Where is tangent positive? 1 and 3. Is that right? You guys okay with that? Uh-oh, we're in opposite quadrants. We're going to have to give the general solution in terms of n pi. Shh. You see what I'm saying? Okay. So the good news is tangent is positive, quadrant 1. So we have to do the quadrant 1 work. Remember, quadrant 1 is a positive here. All trig functions are positive. So at 1, square root of 3. What's the hypotenuse? Do you guys know? Opposite over adjacent. The hypotenuse is what? 2. What does that mean about x? What does x have to be? Isn't 30 degrees? Pi over 6. Isn't that have to be 30 degrees, if you guys remember? Pi over 6. So here's my first what? Solution. Yes, it's purple because that's pi over 6. It's the reference angle, but it's also the solution because tangent was positive. Now, if you're awake, I'm going to do this here. What's the other solution here? I'm just going to give you a remark. You don't need to do this. You know why? If this is general, I can just say x is pi over 6 plus what? N pi. I am done. N is an integer. Okay, you guys okay with that? It's over here. That's the solution. You say why? Because the solutions are in what? Opposite quadrants, 1 and 2. So I could get the next one by simply doing what? Rotating pi. Or I go in the other direction, subtract pi. So if you like, you can say, hey, I just want to get the other solution, I can say, okay, add that pi. Is that right? Multiply by 6. 6. The second solution in quadrant 3 is simply going to be what? 7 pi over 6. And there you go. Okay, now you don't need to do this. You say, why don't I need to do it? Because they're asking us for the general solution. You say, how do I know? There's no restricted domain. So if it's blank, if they don't say, hey, we want these, what, solutions between 0 and 2 pi, well, guess what? They didn't restrict your domain. This is over all what? All real numbers. So if that's the case, and you're awake, you go, you know, I have this alternate quadrant solution. Mr. Judge pointed out to me that differs only by pi. Well, you're done right here with this general solution here. This is that general solution. Okay, I mean, we're going to put the phrase, what? The general solution. Done. What do you guys think? Pretty good? Not too bad. You're solving trig equations. This is a big deal, ladies and gentlemen. You got to solve a trig equation in your life. This is interesting, though. Some of these are going to be a little bit longer than others. So I'm going to have to need some space, but they're kind of interesting. Let me share with you guys this here. You see this 2 cosine squared minus 1 business? So remember what we did yesterday. We're going to have to solve again for cosine, but notice if we add 1, we get 2 cosine squared is 1, divide by 2. Now we get cosine squared is what? 1/2. Is that right? Here you go. Do you guys know how to solve these kind of equations? Right? You know what cosine is? Plus or minus square root of 1/2. What did you guys use here? Cosine squared. What did you guys use? You had to use the what? Square root formula. We did that yesterday. Now, you got to have to simplify this over here, though. Okay, so you got square root of 1 over the square root of 2, quotient rule, which is 1 over the square root of 2. So, ladies and gentlemen, you have cosine being what? 1 over the square root of 2. But you got 2 solutions. Plus or what? Minus. So, you got 2 solutions here. Cosine is going to be what? Positive. Cosine is going to be what? Negative. 2 solutions here. Got to move this. Okay? So you got 2 equations now for the price of 1. That's how this is different. 2 equations for the price of 1. So I'm going to do this here. I'm going to say to you guys, you know, this is where cosine's positive. I'm going to have to do some color coordination here. This is where cosine's positive, right? And this is where cosine's negative. I'm going to just share with you guys a couple of things here. Let's get this bigger. All right, let's ask you guys this question here. Where's cosine positive? What quadrants? 1 and 4. Is that true? And cosine's negative in quadrants 2 and 3. So I need the quadrant 1 reference what? Angle. So, I mean, I have a way I can call it the reference, which is good, or I can just say, hey, that's going to be a what? Quadrant 1 angle. It's my solution for a positive cosine. So, adjacent is 1. Square root of 2 is your hypotenuse. Is that right? So then what does that make the opposite side? Is that 1 as well? Do you guys recognize this? What's that solution? Isn't this going to be here 45 degrees? Pi over 4. Okay? So this is my first solution here, pi over 4. It's right here. Yes, it's the reference angle, but that's fine. Now, let's see if you guys are really awake here. We can do this very easily. I mean, how about if I do this? I know that orange is positive and green is negative. Can I just get a way of doing the following? The logic that we already had, which is what? Pi over 4 now plus what? Why can I get away with that? Because what I'm talking about now, ladies and gentlemen, is these are in opposite what? Quadrants. I got to get a highlighter. Aren't these solutions in opposite quadrants? Because this has to be what? 45 degrees as well. Pi over 4. We have to give the general solution, okay? Not the particular, but the general. So I can get the negative, the green one negative, because they're in opposite quadrants. So I killed 2 birds with 1 stone here. Okay, you guys with me on that? Because of the opposite quadrant scenario. This differs by, I think I want to use red here. This is just pi, right? So I can alternate all day long by adding a multiple of pi or subtracting a multiple of pi with my revolutions. I get the coterminal solutions here because they're in opposite quadrants. Now, what would be your game plan to get the other 2 solutions? Because there's like 4 solutions here. Right? You guys see what I'm saying? You have what over here? This is another solution, by the way. And then this is another solution here. So here's what I would say to you. I'm going to get rid of this. Okay? Get this solution. You have to know what that angle is. Even though it's negative, doesn't matter. If I can get that solution, and I can, because I have the reference angle, what's the quadrant 2 solution going to be? You guys know? This is going to be what? Pi. So I have to do what to get that solution here? I'm going to rotate pi, and I'm going to back up what? Pi over 4. So this is pi minus pi over 4. Do some arithmetic. 4 over 4. What does that mean? That the second solution in general is going to be what? 3 pi over 4. Okay? Because you have over here on the side here, so we're talking about 4 pi over 4 minus 1 pi over 4 gives you 3 pi over 4. But we got to give the general solution. And what's happening again? This is a quadrant 2 solution. We could describe the quadrant 4 solution because it's in the opposite quadrant. So what does that mean? If it's in the opposite quadrant, just do what? Add a multiple of n pi, where n, again, is a nice what? Integer value. So this is giving the general solutions, ladies and gentlemen, all solutions here, even though some are positive, some are negative. So this is kind of a quick and easy way to get your general solution. And if you're looking back at the book, this is what you're going to see. Okay, you guys okay with that? That's kind of an important thing here. General solutions. Easy breezy, lemon squeezy. Not too bad, the general solutions. So when they start your whole thing here, you know, and I'm going to give you guys another one that's kind of interesting here. Couple of these here. You're going to say, well, what happens when it's secant and so on? You know, you'll see. But this is kind of an amazing thing. It's kind of efficient if we approach it this way. You guys see what I'm saying? Looking at the whole picture and thinking of the opposite quadrant scenario. Getting coterminal angles. All right, what about this? You say, okay, you have to solve for what? Secant squared. So number 4, we can say this is secant squared equals what? 2. Now that's 2 over 1. What do we know again? What does that mean? That means what's the reciprocal of secant squared, or the reciprocal of secant is cosine. Is that right? So we just flip over these fractions. Easy breezy, lemon squeezy. So now, what does that mean? That means cosine is what? Plus or minus square root of 1/2. Because what did you guys have to use algebraically speaking? You had to use a square root formula. And when you simplified this radical, like before, you get 1 over the square root of 2. Is that right? So cosine plus or minus 1 over the square root of 2. Now, I think I have what here? Deja vu. Oh. Didn't we see this before? Cosines plus or minus 1 over the square root of 2? So what do you think we want to say for number 4 then? I'm going to say what? Let me do this. Let's copy this. I'm going to say see what? Prior example. We had those solutions already in general right here, and you're done. Copy. Because we did this one already. That was a prior example. Easy breezy, lemon squeezy, right? All right. Stand number 5. So number 5 is done just like we did the last few. Cosine becomes what now? 4, right? Or cosecant squared, right? Now, this is 4 over 1. What are we going to say? What's the reciprocal of cosecant? Anybody know? Isn't that sine? So this means sine squared is what? 1/4. Sine is going to be what? What is sine? plus or minus square root of 1/4. What is this going to be? Square root of 1/4 is going to be what? Let's simplify. Square root of 1, square root of 4. This is 1/2. Sine plus or minus what? 1/2. There's two answers here. Sine is positive 1/2. Sine is what? Negative 1/2. Does that look like okay? Is that you guys okay with this one? Okay. Let me move things out here. So let's go look at our all students take calculus here. Where is sine positive? Quadrant 1, quadrant 2. Is that right? I just want to make sure you guys okay with that? Now, where is sine negative now? Right here. Is that true? So we're going to have this opposite quadrant solution because remember, keep in mind, they didn't restrict the domain. They want us to give general solutions here. Okay, now what do we have to do? Do you guys know? We're going to get the reference angle, right? Because we're going to have to try to find that angle here. So what does it mean for sine to be 1/2? Anybody know? What does that mean? Huh? What's the definition? Isn't this opposite is 1? This is 2. Then what's the adjacent side? Is that the square root of 3? I think so. Is that right? So what's the special angle? Is that 30 degrees? 5/6, this has to be 30 degrees, right? Okay. So we got the special angle here being what? 5/6 or 30 degrees. So what could we do? Do you guys know? We got 4 solutions. Okay, so this is also that 30 degrees here, 5/6. Now, since they want the general solution, what should we just do? We just say 5/6 plus what? N pi. Because we're going to get, again, here, the opposite what? Quadrant phenomena for solutions here. Yes, one is positive, one is negative. Okay? And then you say, how do I get this scenario? Well, this is also here, by the way, 5/6. And remember, we got the 4th solution over here. We can do that. which is what? Pi over 6. So once we get this solution, what do we know? Opposite quadrants. So how do we get that second solution here? It's pi minus what? Pi over 6. That's what we seen yesterday. So 6 over 6, what does this give you? 5 pi over 6, is that right? So now we get x is 5 pi over 6. The opposite quadrant phenomena of solutions here, just add a multiple of n pi, and ladies and gentlemen, n is integer, and you got your what? Solutions here. Okay, you guys okay with that? Easy breezy, lemon squeezy. So when you see the squares here, don't kind of panic. It's what? It's doable. Now, this is going to be an interesting scenario as well. These last three in this list here. Okay, it's going to be interesting here. Now, you say, why is that so interesting? Well, here's the deal. Solve for tangent. Okay. You're now going to get tangent going to be what? 13 over 2. Now, I don't know if you guys are awake or not, but I'm going to ask you guys this question here. Here's the angle x. What's the definition? Opposite over what? Adjacent. And then I'm going to say, is this a special triangle? Anybody know what I'm saying? Is that a special triangle? I mean, Pythagorean theorem is going to say what? Square root of 2 squared plus 13 squared, square root of 4 plus 169, square root of 173. Is that a special triangle? You see what I'm saying? What do you think the answer is? Is that a special triangle? So, Mr. Judge, did you forget to teach me about another special triangle? I'll say no. There's only 2 special triangles. So, this is no longer a question. This is now a statement, okay? I'm going to say, this is not a what? Special what? Triangle. So if you don't have a special triangle, what do you think they're going to ask you to really do here? It's not a special triangle. I'm going to ask you guys this question here, right? What is the angle x here? Okay? What is x? Well, we're going to have to wake up the TI. Make sure your TI is in degree mode. Okay? Doesn't have to be. It could be in radian mode. But I want you guys to understand something here. I'm going to have to do what? Here's what I'm going to say. You know what x is going to be? The inverse tangent of what? 13.5. I know you can't see it. And yes, 13 halves is actually 6.5. Let's see what x is going to be then. So I have to look for inverse tangent. Okay, I'll put 13 divided by 2. You know what this is? This is like 81 degrees. Okay? (81-degree angle. Okay, you guys with me? So if I said to you, they asked me for this general solution, okay? Right? Isn't this tangent now? You're really solving this tangent here? 6.5, 81-degree angle. That's why you guys had to learn about inverse functions, inverse tangent, inverse sine, inverse cosine. So when I go back now and I say, okay, here's my angle. It's quadrant 1, by the way. I know all students take calculus because they're asking a general solution situation. If I can make it bigger, please. Where is tangent positive? Remember, tangent's positive, 3 halves, or 13 halves, 6.5. 6.5. Tangent's positive again in quadrant 1 and quadrant 3. Okay? So this is a pretty steep angle. This measures 81 degrees. It's also the reference angle. This is 81 degrees. They asked me for the general solution. So if you said x is 81 degrees plus, let's be careful, plus what? And pi. Why n pi? The solutions again are in what? Opposite quadrants. Easy breezy, lemon squeezy. They're opposite quadrants. However, you're going to say, Mr. Judge, I have an issue here. Okay? And I'll say, okay, I understand n is integer. That's not the problem. But you know what? Pi is in radian measure, and you gave your answer in degrees. Okay? You guys with me on this? So you might say, well, what can I do? Well, a couple of things. Go back to your calculator. And maybe you go, okay, let's go to radian measure. I just wanted to say to you, change that to radian. Okay. Second, inverse tangent, 6.5 or 13 halves. It's the same thing. This is about 1.418. Is that right? Okay. So we can say 1.418 plus n pi. Okay, now this is in what measure? Radian measure. Okay, so you're now consistent, and that's important. These are now in radians. Okay, for the simple fact that, 81 degrees is the same as 1.418, but in radian measure. So now you're consistently in radians. So what do you guys think? Easy breezy, lemon squeezy? So you can actually use your calculator to do this. This is what they intend. Now let's see what happens here for sine being negative 0.2. What do you guys know? You might say, I don't think there's a special triangle that has this. Well, go back now and let's go back to all students take calculus, and let's kind of do it from start, from first principles again, and say, okay, sine is what? Remember, this is negative. What quadrants is sine negative in? 3 and 4. Is that true? Easy breezy lemon squeezy. So I still need the positive answer. Sinus 0.2. Now, I don't know what the angle is. Okay? I just know this is my reference angle. Okay? So the reference angle is inverse sine of 0.2. Going to find the reference angle. Quadrant 1 is your reference quadrant. So if I want to know what this is actually personally in degrees here, okay? I'm not going to give the final answer yet. So, God, it's kind of weird here. There we go. Okay. So I'm going to change the mode. I want to go down. Second inverse sine of 0.2 now. Do you guys know what that means? This is about 11.5 degrees here, okay? So I'm going to keep that as a decimal. I can. Maybe, maybe not. Should we go to radians? I don't know. Should we approximate that 11.5 or 12 degrees? Let's approximate. Let's go to 12 degrees. It's okay. Just want you guys to see this. This is 12 degrees. This is 12 degrees. Okay? It's the purpose of the reference. So this is the positive. We don't have a positive sign. It's negative. So now we go, okay, what quadrants here? 3. How do we get this quadrant 3 answer? Do you guys know? How do we do that? Let me share with you guys what that is. Okay? Remember how you get a quadrant 3 solution. You rotate pi and you rotate the addition of the reference. Is that right? So it's actually going to be what? Pi plus that what? 12 degrees. And then we have a consistency issue. So I guess we're going to have to go out to what? Let me double check how your book wants to write the answer. Huh? There's no what? I'm sorry, I can't hear you. Well, we're not done yet. We're not done yet. We're just here trying to find that angle. I'm just going to double check to see how your book wants to write those kind of solutions. Does it keep it how? You know, in case you guys, it's always good to look at the examples too in the book. And yeah, it looks like the book keeps it numerically. Mean a radian measure. Let me double check here. Yeah, your book does some kind of interesting. You know what you know what your book does? Here's what your book does. The book just keeps this answer here. So if you said, what is the book going to do? The book says, oh, the angle is inverse sine of 0.2. Okay? So you say, what did the book do? I just want to be consistent. That's an angle. So now it doesn't matter if it's degree or radian. Okay, they're saying that this is this portion. Okay, it's 12 degrees, by the way. But don't forget, it's a quadrant 3 answer, so you're going to have to do what? Pi plus that. Okay, and then don't forget to do what? We're going to have to do the general solution part. And this is going to blow your mind. So the angle that we just got right here, this is what I want to remark here. The book wants you to write this angle this way, as pi plus inverse sine of 0.2. Okay? And that's how they get it. So they're going to make it easier on you. You write it symbolically, not numerically. Now, let's ask you guys this question here. You guys ready for the kicker? This is an important detail. If I'm going to get all the other coterminal solutions to a quadrant 3 solution, how do I do that? Remember, this is going to be my first solution, and then I have to rotate what? Another 2 pi. Rotate another 2 pi. Rotate another 2 pi. Or go in the opposite direction of 2 pi. Opposite 2 pi. Opposite 2 pi. Here's my point to you. You do not have, be careful here, you do not have the opposite quadrant scenario. So you don't have the opposite quadrants. If you don't, what do? Add 2n pi, where n is an integer again. So ladies and gentlemen, because your solutions are not in opposite quadrants, you don't use n pi. You use what? 2n pi. That's the deal. That's it. You use 2n pi. So this is how your book handles those kind of scenarios here. But there's two general solutions. You might say, what's the other general solution? Well, you're now going to have to get what? The quadrant, let me go back, the quadrant 4 angle. Yes, this is 12 degrees, but how do we get the quadrant 4 solution? Do you guys know? Yeah, let me borrow this one over here, okay? So here's what we do. Oh, I guess I can't borrow it. I'm going to rotate 2 pi, and then I subtract what? 12 degrees. So you say rotate 2 pi. Yes, that'll be 2 pi now minus 12 degrees. And you say, no, Mr. Judge, it's not minus 12 degrees because the book does what? It uses the symbolic answer of what? 2 pi minus, it says inverse sine of 0.2. Okay? Like this one here was pi. First general solution. This is a quadrant 4 solution. But don't forget, you're not bouncing with opposite quadrants again. So for that solution, you have to add a what? 2n pi in general to get all other coterminal answers for that second solution. So we're doing two things. We're dealing with the notation and how to write your solution here. And this was different, okay? You're not bouncing opposite quadrant solutions. You're not rotating those pi, multiples of pi solutions. This is 2n pi now. So these are kind of the, kind of some questions I have in the book here for you. I just like to get the angle because I want to know what it is. 12 degrees. It's kind of interesting. And then you say, what about this? Well, there's no again here what? There's no what? There is no special triangle here. So x is going to be what? Inverse cosine of what? Of 0.8. Now, we don't know what that is. I'm going to find out. And I'm going to make sure I'm in degree mode. I am. So second cosine 0.8, that's almost 1. It's about 37 degrees. Okay. But don't forget, all students take what? Calculus. It's on a fold there, and you doesn't like it. Okay, so I'm going to move everything down. So notice cosine's positive, right? Solutions are in what? Quadrant 1, quadrant 4. $37 degrees. Also what? 37 degrees. Are your solutions in opposite quadrants? Say no. So for this first solution here, up here, back of the book, you'll say my first general solution is going to be, they don't use 37 degrees. Okay? I'm going to move it over. They use what? Inverse cosine 0.8. And then they're going to say plus what? 2n pi. Why plus 2n pi? Well, you're getting all other coterminal solutions, but why 2n pi and not n pi? It's not in opposite quadrants. Sorry, you guys can't see. Okay, so you're going to use, and then n is a what? N is an integer. So you say, what about the second solution here? Well, it's what? 2 pi minus what? Inverse cosine of 0.8, and then don't forget to add your 2n pi, because this is all about getting the general solutions today. Okay, you guys okay with that? And let's make sure this is boxed because, you know. So I just want to make sure you guys understand that this 37 degrees is represented this way. You know, 37 degrees. I know it's the reference angle as well because cosine's positive, but. And it's no different if they even had, for example, they said the square root of 2 cosine x minus 1. Let's do plus 1 is 0 here. Okay? Share with you guys, I would do minus 1. It's okay. Share with you guys the process that was done here. Yes, you got to solve for cosine. So you add 1. And yes, you say, oh, this is cosine of 1. And don't forget the square root of 2. And yes, you divide square root of 2. So yes, you get cosine x is what? 1 over the square root of 2. Cosine is positive. So same process here. Where's cosine positive? Quadrant 1, quadrant 4. So you say, what angle is this? 45 again, is that right? So this case this is adjacent, hypotenuse. This case it was a special triangle. And yeah, that's 45 degrees. Pi over 4. Okay? So this is what they're saying. This is measuring pi over 4. Yes, it's our what again? It's also our reference angle. So for the general solution, though, because they didn't restrict our domain, are the solutions bouncing from opposite quadrants, or they're not opposite quadrants? They're not. So what do I do? Add 2 and what? Pi. Okay? N is an integer, but notice our solutions are not in opposite quadrants. Okay? You guys okay with that? That's my point to you guys. You guys have solutions that are in adjacent quadrants, I guess we should say. So adjacent quadrant solutions, you have to add the multiple 2 and pi. So you might say, how do I get the next one? Well, you guys know, how do I get this angle? The quadrant 4 solution is always going to be, so this is my first general. It's going to be what? 2 pi minus pi over 4 plus 2n what? Pi. N is an integer. The only thing here, and this is what we're saying, we just got this angle here. This is x2. And this one was x1. But remember, you have to do some what over here? You got to do some arithmetic. So multiply this by 4, this by 4. So x2 will be, this is 8 pi now, right? So it'll be 7 pi over 4 plus that 2n pi. This is the second general solution. And then this is going to be the what? First general solution. Because this whole portion right here is 8 pi over 4 minus pi over 4, which gives you what? 7 pi over 4. So general solutions really are not as bad as people what? Think. And, just to kind of remark here, you see this n. N is an integer, and that's something that you always want to remember. N is an integer. And what are your integers? It's this set of numbers. -2, -1, 0, 1, and 2. Okay? So when you get the general solution, this is a more, what should we say, a formulaic. It's a formula of what? Of solutions. These are all solutions over the real number line. All these coterminal solutions. So this is like a nice formula representation. Now, and you let n is 0, and you let n is 1, you let n is 2, you let n is 3, n is -1, n is -2, n is -3. You get all these general solutions here for it. But it's not the most practical way to generate solutions, in all honesty. Like if you had to generate like 20 solutions for some reason. Not practical at all. Right? So here's going to be the question for you guys here. What is the more practical way to generate solutions. Okay, just kind of throw that out. What's the more practical way? Do you guys know? It's called the sequential solution format. Sequential solutions is the most practical way. Now you might say, well, what do you mean by that? I'm going to go back up to this first one here, okay? I'm going to say we can do that for both of them, but let's take a look at this, right? It's very simple. I'm going to have to remember this is a fraction right here plus a whole number. You okay with that? And we have to add. So here's what I'm going to remark. Remember that denominator is 4? I'm going to multiply the top by 4 and the bottom by 4. So that's kind of my first step. So that first general solution becomes pi over 4 now plus 8 and pi over 4. Because the order in which I multiply doesn't matter, right? 2 times 4 is 8. Okay, you guys okay with that? And at this point now, let me say there's a couple of things I can do here. Focus on this here. See that multiple pi over 4? See how it's in both terms? I can factor that out. So factor out the common multiple of pi over 4 here. Now you say, what does that give you? Pi over 4 times 1 plus 8 n. N is an integer. This is just for the first general solution. This is nice and what? Practical. Do you guys know why it's nice and practical? Just let n be 0, n be 1, n be 2, and so on, or n be what? -1, n be -2. You can generate what? Your solutions easy. And this is just only one part. So you say, okay, what is x? Well, if n is 0, it's just pi over 4. Is that right? What if n is 1? Replace this with a 1. What's 8 times 1? 8 plus 1 is what? 9 pi over 4. N is now 2. What's 8 times 2? Plus 1 is, this is 17 pi over 4. Okay, n is 3. 3 times 8 is 24, plus 1 is what? Did you guys see my point? N is -1. Well, 8 times -1 is -8, plus 1, that's -7. -7 pi over 4. N is -2. Well, that's -16 now, plus 1, that's negative what? I can do this all day long. So the point is, the sequential form is the most efficient way to go about generating solutions if you had to generate numerical solutions. Now, this is just for x1. You could do the same thing for x what? 2 here. Okay? You go, what do you mean we could do the same thing for x2? Yeah, you could do that, meaning, what did we just do? We took that 4, is that right? And we multiplied, we added the whole number with the fraction, really. So that x2 now becomes 7 pi over 4 plus what? 8n pi over 4. Now, notice the common multiple of pi over 4. What can we do here? Factor it out. You go, okay. It's pi over 4 now, and this will be what? 7 plus 8n. N is an integer. So, ladies and gentlemen, this is a sequential format that's very easy to generate, and it's very easy to use. And if you ever said, oh, you know, now n is 0, you get 7 pi over 4. You knew that one. N is 1. Oh, 8 plus 7 is 15. 15 pi over 4. You said that wasn't in the list, but it is now. N is 2, N is 3, or N is -1, so on. You can generate solutions. So the sequential form is the most efficient and effective way to do that. So what I'm going to do now for you guys is this. I'm gonna add to your homework, and I think I did up to what? What did I do last time for your homework? Remind you guys, we're going to try to get to these what? All of these examples today. We're going to try to do that. What do you guys think? And it's going to be about looking at here, ladies and gentlemen, the general solutions here for these, okay? So we're going to try this out. What do you guys think? Does that look ambitious? I don't know. We'll see. We'll see. So this is all based on the algebra we did a few days ago. Okay, so remember, we solved some equations a few days ago doing some algebra in the x portion. So I'm going to start here with this first one here. And remind you, algebraically speaking, you're going to use here, this is a great thing. I'm going to say, what do you mean? Well, what do we have? Let's get out the right highlighters here. We got a product that's equal to 0. You got a product equal to 0. Product equal to 0. What do you guys use? It's called the zero product rule. You guys want to use that rule, ladies and gentlemen. And what that rule is, again, if you guys remember, if you have a product of two terms, we do. If you have that, there's the first term, here's the second term, and it equals 0. If you have that, then what can we say? Then either the triangle was 0 or the what? Square is 0. Okay? So that's the deal this morning. All right? And there you go. It's called the zero product rule, ladies and gentlemen. Okay. Now you say, what does that mean for me? I typically, at this point, really, I do a T. So if you guys look at this, you go, how come yours looks different? Well, this T is not special. It's just separating your paper into two sections. So it's like saying, we're going to say sine is 0 or 2 cosine x plus 1 is 0. Okay, so this is the zero product rule. It gives us really two equations to solve. Okay, now one is already solved. The first one on the left is already solved, so we're happy about that, right? So this one is solved on the left. On the right, we're going to have to subtract 1, and we get 2 cosine x equals -1, and then we divide by 2, and now we got cosine x is -1/2. So, ladies and gentlemen, we really have two equations to solve here. Okay, so this is kind of what this is about this morning. We're going to do some, hopefully we can get as much done as possible. Okay, so there you go, ladies and gentlemen. So we're going to focus on each one individually. Okay, sine being 0, we got to be careful here. Okay, because even though this is all about the general solution. There is no restricted domain here. We have to think about the restricted domain, though. Okay, I know we're going to get the general solution, but remember, some of these here, this isn't going to go away, this idea that I'm talking about. If we say 1, -1, if you remember the sine curve, right? Yeah, I always have to draw this picture, even to this day. Okay, even though I have the picture in my head, I can't ask you guys, I can't lecture in my head. Some have tried, and they're not successful. I can't say, hey, get in my head and see what's going on. So sine, remember, sine being 0, this is a special situation. This is asking for the intercepts. Okay? This is asking for intercepts. So what we're really saying here, what are the x-intercepts? This is an x-axis. This is a y-axis. That means x is 0. That means x is pi. And that means x is a 2 pi value here. Okay, so all of these are solutions in a restricted domain, ladies and gentlemen. Okay? So this is in a restricted domain. This is the domain being restricted from 0 to 2 pi. We have to give the general solution, right? Because there's no restriction on this today. I want to share with you guys how to go about it, because this is how it looks in some of your homework questions in the book. So there's no restriction for sine being 0. So what I'm going to do now here is this. I'm going to bring in our all students take calculus. I'm going to do that for a very good reason. Oops. Don't know what I just did. Let's always go through this. And remind you about these solutions. This is x is 0, this is x is pi, and this is x is 2 pi, ladies and gentlemen. And maybe we should just keep this as an orange color to express to you guys really what's going on here, okay? We're going to keep that color, whatever color that is. These are my solutions for sine being 0. This is where sine is 0. When x is 0, x is pi, 2 pi. Here's my point to you. The angle, the first solution is right here, right? The second solution is right here, pi. So we have two solutions represented here so far. The third solution is right here again. Okay, you guys see what I'm saying? X is 0, x is pi, x is 2 pi. What's my point? You guys remember my point I've been making the last few days? Aren't these solutions alternating in opposite directions? Opposite directions, meaning opposite, they're not opposite quadrants, opposite directions of 180 degrees, which is pi radians. So if you're alternating that way, the general solution, ladies and gentlemen, is just simply n pi. And again, is an integer. Your book says k, doesn't matter. K, n, sometimes they say j, but ladies and gentlemen, this is the first part of your solutions I want to remark. Okay, these are the three solutions that we got. So they alternate in opposite directions, and so we get to use the n what pi here situation like we've been using. N is an integer. So we've been talking about that, for at least yesterday. Few days. And that now brings us to the other solution here for cosine. Okay. Now cosine x is -1/2. You guys remember we have to go out to the positive value for the reference angle. And we're going to deduce the special angle here for this. Adjacent, hypotenuse, that's square root of 3. What's the angle? It's 60 degrees. Pi over 3. This is a 60-degree angle. This is the quadrant 1 reference angle. This isn't even my solution here. Okay? So this is the reference angle, quadrant 1. I'm just going to highlight that, reference. But cosine we know is what again? Is negative. Well, where is cosine negative? Which quadrants? All students take calculus. Quadrant 2, quadrant 3. Okay? So you're going to have a quadrant 2 angle and a quadrant 3 angle here. Okay? And let me go back here. If I draw an arrow. Oh, come on. Let's draw an arrow. Yeah. Okay. Quadrant 2. Sorry. And quadrant 3. There we go. There we go. So remember, reference angle of what? 60 degrees. Reference angle of what? 60 degrees here. Okay, pi over 3. So for the cosine being negative 1/2, notice our solutions are not in opposite quadrants. Is that right? So this solution here will be x will be what? Pi minus pi over 3. And this solution will be pi what? Plus pi over 3. Okay, we've seen this the last few days. And of course, you have to do your arithmetic. 3 over 3. 3 over 3. And what do you guys end up with? What is this? This would be 2 pi over what? 3. Okay, so this is my quadrant 2 solution. And then this other one will be what? What is this going to be? 4 pi over 3. Quadrant 3 solution. Now, these are not in opposite quadrants, ladies and gentlemen. Okay, you with me on this? So if they're not in opposite quadrants, here's what we say. Let's go back to the quadrant 2. This will be now what? 2 pi over 3 plus what? N pi. And this will be what? 4 pi over 3 plus n pi. Oops, I apologize. Apologize to you. Yes, it's actually what? 2n pi. 2n pi. I better wake up. Because this is why I emphasize the graphical picture that I'm showing you guys. This is why I'm drawing all the solutions here. Because remember, this is not the opposite quadrant situation. Here's what I'm saying. This must be to get all coterminal what? Solutions. This is the first quadrant 3 solution. And then this is the quadrant, sorry. The first one's quadrant 2. And the second one is quadrant what? 3 solutions. The picture is right here. But don't forget, what did you have to begin with? The other was sine. So if you're looking back at the book, oh, we don't want to do that. Okay, I'll just write it down. Since it's not too much to write down n pi. If you look in back of the book, ladies and gentlemen, what are you going to see? Yeah, this is the orange. This is the sine being 0. You're going to see all 3 of these here as a general solution here. So I just want to remark, that's kind of how you go about solving these. And then let's do another remark. Right? What about the what? Sequential solution. I mean, do we have to do that? No, but we're not going to do that for now. We're going to leave it this way, okay? Maybe one day I'll do a sequential solution video. Separate sequential solution. Okay, you guys okay with this? So you're looking at all the solutions, orange and green, these angles. Okay? So that's what I kind of wanted to do this morning, is go through the visual of these kind of problems, because these are some of the algebraic, what I call, algebra trig equations are more algebraic here, and sometimes we have that. And so let's continue and notice again, we have to use the zero product rule again. So what does this mean by the zero product rule? You guys remember, break out your t now. The t just separates your paper. Tangent minus the square root of 3 equals 0. Cosine x plus 2 equals 0 here. Now add the square root of 3 to both sides, and you end up with what? Tangent equals the square root of 3. Subtract 2 from both sides, and then you have cosine equals negative 2. Okay? So I just want to kind of remark, you got the orange and you got the green. We're going to look at it that way. Now, I'm going to go to the green. I'm going to ask you guys this question here. Does this ever happen? Right? For cosine being negative 2. This what? This never happens. How do we know it never happens? Well, look at the cosine curve. Right? Remember the maximum value for cosine and the minimum value, the domain is between negative 1 and positive 1, right? Well, range, sorry, you're actually right. Oh my gosh, maybe I should go take a walk in the park. Now, we don't really have to draw all the detail, but as you demonstrate to people, you certainly might want to, right? Let me do this if I can. This is where negative 2 would be. And what do we know? The range, this never happens, is what we're saying. The range is between negative 1 and positive 1. It can't be ever negative 2. This is impossible. Okay. All right, but tangent could be the square root of 3. And again, tangent is positive. Is that right? So if we say, well, where is tangent positive? We're going to have to bring in our all students take calculus. Okay, you guys okay with that? So tangent is positive in quadrants what? 1 and quadrant 4. 3. So let's go to the reference quadrant, or we don't even have to do that anymore. We know what's going on. It is the quadrant 1 solution here. So here's x, square root of 3, 1, and this will be 2. Is that right? So what's the value of x going to be? Isn't that 60 degrees? Pi over 3. Okay. So we're going to get the opposite what? Solutions again. And I guess I was using the arrows earlier. So, or the highlighter. I guess I'll still do that. Okay. 60 degrees. So you have the opposite solutions again, opposite quadrant solutions. So you know what that means? Here's what this means. Take one of the solutions, take the quadrant 1, and then add a multiple of n pi. N is an integer, and ladies and gentlemen, right, n is an integer, and that's all you need because you have the opposite quadrant. Remember, this rotating both clockwise and even counterclockwise, well, that differs by pi. Okay? One's positive, one's negative. So this one's negative if you want to think of it that way. And integer values includes the negative numbers. So there you go, ladies and gentlemen. Easy breezy what? Lemon squeezy. This is the quadrant 1 answer, but again, you can get the coterminal solutions by just rotating pi either direction. And that's what you'll see in back of the book for this question here. Number 2. Okay? You guys okay with that one? Easy breezy, lemon squeezy? Okay. Let's see what number 3 is. Number 3 is interesting. Because up until now, you didn't have to factor. They were already factored for you. I'm going to say factor out the greatest common factor. Now you say, what's the greatest common factor? Sine, ladies and gentlemen. Sine is common. So as a quotient, you're going to have tangent plus 1 here, and that will equal 0. So you said we have to factor out sine, and we did, okay? You guys okay with that? So now, I guess we're going to have to do a little bit of algebra. We're going to have to factor now. So, ladies and gentlemen, now we get to use the what? The zero product rule. And I'm going to go back to our original color scheme. Okay. And we end up now with what? Sine being 0. Tangent plus 1 being 0. Okay. Orange, green. Now, what do we know about sine being 0? We did this already. What's the general solutions? N pi, where n is an integer. So we already know that one, and that's pretty good. Okay, you guys okay with that one? Well, subtract 1 here, and we get tangent equal to -1 now. Okay, do you guys remember this here? Do you guys know the solution where tangent's -1? Maybe we got to get out all students take calculus. We are learning this. By now, we've seen it a few times, so you might even know already. I think I know what that is. But let's go over all the details. Okay. Remember, tangent is negative in what quadrants? This is green. Tangent's, that's not green. This is green. Tangent's negative in quadrant what? Quadrant 2, quadrant 4. Opposite what again? Opposite quadrants. So we know how to handle opposite quadrants. And in fact, remember this, we got to go to the quadrant 1 reference angle. We got to answer where tangent is going to be what? Positive 1. And we know what that is. What's that angle? 45 degrees, pi over 4. So we've seen that one over and over. 45 degrees, ladies and gentlemen. So what that means is this reference angle is what? pi over 4. And it means this opposite reference angle is also pi over 4. That's the reason why you find the reference angle. So just get the quadrant 2 solution. You say the quadrant 2 solution is when I take pi and I subtract the reference. Is that right? This is a quadrant 2 solution. Reference. So you might say, isn't that 4 over 4? It is. And what do we get now? Do you guys know? 4 pi over 4 minus the pi over 4. What does that give you? That's your 3 pi over 4. Okay? Now, this is the here. That's your quadrant 2 solution here, ladies and gentlemen. Okay? Now, remember, you're going to alternate quadrants. They're in opposite quadrants as solutions. So we know when it's opposite, not adjacent, we add the multiple of n pi. Again, we should say n is an integer. This is the way of saying that. I just want to remark, here's your n. N is an integer. So, ladies and gentlemen, here's how we get our what? Solutions here. Easy breezy, lemon squeezy. And that's how we handle number what? Number 3. Good job. So all pre-Thanksgiving. Number 4 is interesting too. All right, let's see what this looks like. Okay, so you get 2 cosine squared minus cosine minus 1 is 0, and that's pretty good. So what do you guys think you do with this here? Do you guys know? I'm going to introduce a substitution. We're going to let t be cosine. If you were taking intermediate algebra or pre-calculus, this is kind of thought of as quadratic in form. I'm going to write that down. Okay, quadratic in what form here? That's really saying if you let this middle term here, t, be cosine, you now get a quadratic equation. That's all that is. Can you guys solve quadratics? Yes, we're going to solve them by factoring. 2t. Okay, do you guys remember how to factor this? This is 1. This is 1. 2t is negative plus t. There you go, ladies and gentlemen. This is factoring here. And then now you get to use the zero what? Zero product rule, because you have the left side, you got the right side. So 2t plus 1 is 0. T minus 1 is 0. 2t is negative 1. T is negative 1/2. Add your 1. T is 1 here. So we don't want to forget what t is. T is going to be what again? You guys remember what t is? Cosine. So what you were really doing all along now is you were saying this. That cosine x is actually negative what? 1/2. You were saying cosine x is actually positive 1. These are your two solutions. One in orange and one in green. So I'm going to keep the t because we use that zero product rule. All right. This is why we had that zero product rule, factoring. This is why we reviewed the algebra a few days ago, so we can solve these kind of equations here. All righty. Now I'm gonna solve the green one first for a very good reason. You know, we already did cosine somewhere, I think. Yeah, when we said it was impossible. Well, this is our cosine curve. I'm gonna borrow it. Okay, because I'm going to share with you guys something interesting here about it. Right? I'm going to borrow that curve. Put it right here. Cosine is 1. Do you guys remember where cosine's 1? That's at a maximum value. Cosine is 1 here and here. And you say, where is here? Well, x equals what? 0 and x equals 2 pi. These are coterminal, by the way, ladies and gentlemen. This is where cosine is positive 1. So it's always good to know the cosine curve. Is that right? So, yeah, I mean, these are kind of the things, like I said, when I took math courses and science courses, and you said, oh, my God, in trig, you know, what did you see? I've seen a lot of these actually happen, you know, where sine is 0 or where sine is 1, cosine is 0, cosine is 1, sine is -1, cosine is -1. Let's try to make this bigger. So in green, we say, what are those angles? Angles are 0 and 2 pi. So where is 0? 0 degree angle is right here. Is that right? And then what about the 2 pi? Same place. So I know, what do I say as a solution? I can say, take the 0, and these are not opposite quadrants or opposite direction. So take the 0 solution and add 2 and what? Pi. What does that really mean? It's 2 and pi, n's an integer. So for what I'm doing is what I've always done. Take that first solution, and then we added a multiple of what? 2n pi to get every coterminal solution here. So I'm going to put it all in the same picture again. Okay, you guys okay with that? Put it all in the same picture. So now you go, what about this cosine? Where's cosine negative? Do you guys know for cosine? Quadrant 2. What else? Quadrant 3. Cosine being negative. But we need, is that true? Yeah, it looks like we need the reference angle. If we're going to get negative cosine angles here, you know, just draw our pictures. Notice something about this as well. I don't want to do that. I want a highlighter. The solutions in quadrant 2 and quadrant 3, they're not opposite quadrants, are they? They're adjacent quadrants. What does that mean? Add 2n pi to both your solutions. Alrighty. So, reference angle information. Cosine is positive. Definition. Right, what is this? Adjacent, hypotenuse. Is that square root of 3? What's the angle again, ladies and gentlemen? Looks like it's going to be what? 60 degrees or pi over what? 3. This is my reference angle. Okay, they're quadrant 2 solutions. Pi minus pi over 3. This is quadrant 2. And this would be pi plus what? Pi over 3. This is your quadrant 3 solution. Again, this is how we use the reference angle. 3 over 3, 3 over 3. What's the final two answers here, ladies and gentlemen? X will be 3 pi over 3 minus 1 pi. That's 2 pi over 3 plus 2n pi. This is the quadrant 2. Right in here. Quadrant 2 general solution. Okay. And the other one will be 3 pi over 3 plus pi over 3 is 4 pi over 3 plus what? The quadrant 3 solution. But don't forget, you had the prior solution. Oops, undo. 2n pi. I'm not going to, seems to not like when I do that. And that was the green solution here. So you're looking back at the book, ladies and gentlemen. And again, what are you going to see? You're going to see these solutions here. All right, ladies and gentlemen, there you guys go. Number 4. Okay. Number 5. Okay, we're going to get a good, this is a very classic question. I see this in a calculus class as a solution. They go, Mr. Judge, how do you handle this one? They go, oh my God, they're stumped. And I say, take trig. And they go, my counselor told me I didn't have to. I said, ask your counselor if they've ever done this before themselves. They go, oh no, they never. Huh? It is required. They did it? Really? Okay. Well, it's good. It should be. You see this? Sine equals cosine? I want you guys to know we're going to divide both sides by cosine. Okay? Now you say, why? This is an important detail. Divide both sides by cosine. Now, on the left, you guys know what sine over cosine is? I already told you it's tangent. Sorry. And cosine of cosine is 1. So this is a classic, ladies and gentlemen, question. It's classic. Now, tangent is 1. Tangent's positive, and you go, oh, I like that. That one's easy squeezy lemon, whatever it is, right? Easy breezy lemon squeezy, who knows? Where's tangent positive? Quadrant 1, quadrant 3. Ladies and gentlemen, it's in opposite quadrants. You go, oh, is that the opposite quadrant general solution situation? And I'll say it is. Okay, now you already know from the past. What is x? Pi over 4, and then plus n what? N pi. You get all the solutions. Today was general solution day, right? There you go. There it is. It's all there in front of you, actually. Oh. Move it here. Oh. See if I can move it. And I'm going to try to draw a better angle. There you go. Opposite quadrants, use n pi. Picture is worth 1,000 what? Words, ladies and gentlemen. Number 5, okay? All right, sine is cosine. Outstanding here. All right, now I'm going to say number 6. I actually want to do 7 first. Do you mind if I do 7? Number 7 is interesting. It's related to number 6. So I'm going to go out of order. And you say, Mr. Judge, I'm going to take the same approach here. And I'll say, yeah, but before you do that, what might you want to consider here? What do you guys notice about this? This should stand out to you. Yeah. These are what? Double angles. You with me on this? All right. We're going to do a substitution. I'm going to let this be my theta. I'm going to let this be theta. Okay? Because now you don't have x anymore. You got 2x. So I'm going to say, let theta be what? 2x. If you do, we get sine theta equals minus what? Cosine theta. And now this looks a lot like problem number 5, actually. It wasn't 6, problem 5. You say, why? I'm going to use sine over cosine again. I'm going to divide both sides here by my cosine. Okay? Cosine. This time, I get tangent theta being -1. All right, you guys see that there? So answer the question. I know it's not x. In the past, you had an x there, but answer the question. Go back to all students take calculus. Where is tangent negative? Two and 4. So you got an angle here. It's a quadrant 2 angle. And then we're going to have a what? Quadrant 4 angle. Opposite quadrants again, ladies and gentlemen. All right. Now you say, what do I have to do? I got to do this here. The reference angle is 1. What's the reference angle? Isn't that pi over 4? We've seen that. So this is a reference. Reference. It's the opposite quadrant situation. So I got to get theta here. This is not x. Theta is pi minus pi over 4. I got to get that quadrant 2 angle. If I get quadrant 2, I'll get quadrant 3. Quadrant 4, I apologize. 4 over 4. What is your theta, ladies and gentlemen? 3 pi over 4. So you might say, do I say theta here is 3 pi over 4? And I say yes, because that's the quadrant 2 solution. But then you say, what about my n pi? Okay, yes, this is now every coterminal angle in terms of what? Theta. All right, so everything looks like what we had before. Okay, and n is an integer. All right, but what's the problem? They didn't give us, sine theta is minus cosine theta. We changed that. We changed that by letting theta be what? 2x. So you might say, what does that mean? Here's what this means. Replace theta with what? 2x. 2x. 3 pi over 4 plus what? N pi. Could you guys solve for 2x? You sure can. Divide both sides by what? 2. So you get 3 pi over 4 divided by 2 plus n pi divided by 2. Because you can distribute the division by what? 2 to a sum there. Okay? It just so happens here we got to know what that means. How to take what? 3 pi over 4 divided by a whole number. A fraction divided by a whole number. We've seen that in this course so many times, and that's going to give you 3 pi over what? 8. So, ladies and gentlemen, here's our solution. X is 3 pi over 8 plus n pi over what? 2. Okay, so I just want to let you guys know this is the general solution. N, again, still is a integer value, but this is how we handle when they deviate from giving us sines and cosines in terms of the single variable x. Now it's double x, triple x, and so on. This is called multiple angles. So I wanted to do number 7 there for you guys. And it's related to number 5. But if I go back and go, okay, what about number 6? 6 is an interesting question too. It's very similar. Say, where's 6 here? Let's find some space. 6 is similar, right? We don't have x right here, do we? You see what I'm saying? This is 2 cosine. So here's what we're going to do. You're going to let theta. We're going to do the same substitution here. We'll let theta be what? Theta is x over 3. And if we do that, what do we say now? Right? We can say what? 2 cosine theta plus the square root of 3 equals 0. All right. So the same procedure now. You go, oh, this is like all the questions we did in our homework. 2 cosine theta is negative square root of 3. Divide both sides, that's a theta, over 2. We get cosine of theta going to be negative square root of 3 over 2 now. Okay, now all students take calculus. Bring that in. Good. Where is cosine negative, ladies and gentlemen? Yeah, all students take calculus. Let's find where cosine's negative. Quadrant 2, quadrant 3. Did we do square root of 3 over 2 before? We need the reference angle. Cosine of the reference angle is the positive angle, square root of 3, 2. So let's get out our right triangle. Definition. Adjacent over hypotenuse. This is what? 1. Is that true? Okay, what's the reference angle going to be? It looks like it's 30 degrees, right? Pi over 6. So we have 30 degrees. pi over 6. So the solution in quadrant 2, if we can draw an arrow, reference, pi over 6, reference. Again, we got quadrant 2, quadrant 3 solutions. So theta will be here in quadrant 2, pi minus pi over 6, and then theta here is pi what? Plus pi over 6. Don't forget how to add and subtract, you know, with a whole number with a fraction. So this is theta is what? 5 pi over 6, and then this is theta is what? 7 pi over 6. Are the solutions in opposite quadrants? No. They're in adjacent quadrants. So what does adjacent mean? Next to? Yeah. So we're going to have to say 5 pi over 6 plus 2n pi, and theta will be what? 7 pi over 6 plus the 2n pi. And n here is a what? Integer. Okay, but you say but wait a minute, Mr. Judge, this is theta. This is theta. What did we say theta was anyway? 6 over 3? Let's go back. Theta is x over 3. All right. So replace this with a what? X over 3. X over 3. What do you end up with? Here we go. We get what? X over 3 is 5 pi over 6 plus 2n pi. X over 3, 7 pi over 6 plus what? 2n pi. What do I do with my 3? Right, we got to solve for x. You're going to multiply both sides by 3. Okay, you're going to have to distribute here, right? All right, let's see what we get. X is going to be, it's going to be 5 pi times 3 over 6 plus 6n pi. And then here, x will be 7 pi times 3 over 6 plus 6n pi. Do you guys know why I did that here? Why did I do this? Because I can simplify easier. Okay, so here we go. X will be 5 pi over 2 plus 6n pi. And then x will be 7 pi over 2 plus what? 6n pi. You are done. There we go. So this is how we handle the multiple angles, half angle, or a third of an angle situation. Okay, you guys okay with that one? Not too bad, I would say. You know, so we did 6 and 7. So now we're going to do 8. So let's see what 8 looks like. I think I know what I'm going to do here. I'm going to copy all of these here. I'm going to bring them down so we don't get, I don't know, dizzy just by looking at everything, right? All right. See what number 8 looks like. Okay. And I think that was a 4. Is that right? So again, you go, oh, wait a minute. What do I have? I don't have x. I'm going to do some what? We're going to let theta. We're going to substitute x over 4 for theta. So you end up now with what? Tangent theta plus the square root of 3 is 0. Okay, and then we end up with tangent theta is minus square root of 3. We're going to bring this in. Where is tangent negative? Quadrant 2, quadrant 4, opposite quadrants. Is that right? All right, we need the reference angle. What's the angle? Looks like it's 60 degrees. Is that right? Pi over 6. Oops. Pi over 3. Apologize. So, pi over 3. Pi over 3. We only need one angle. Pi minus that reference of pi over 3 here. Okay? And so if we do the arithmetic, it's 3 pi over 3 minus 1 pi over 3. The quadrant 2 solution is 2 pi over 3 here. Okay, but what do you guys know about those solutions? Opposite quadrants. So in general, we're going to say what? Theta will be 2 pi over 3 plus n pi. N is an integer because it's in opposite quadrants. Then you say, but this is for theta. Theta is really x over 4. So we did the substitution. So, okay. Replace the theta with x over 4, and we get x over 4 is 2 pi over 3 plus n pi. You got to solve for x. How do you guys solve for x? You multiply 4 to both sides. Okay. It's going to cancel on the left. So we get x is going to be, final answer, I think we can, x. Distribute your 4, 8 pi over 3 plus what? 4 and pi, and n is your integer again. Distribute. So this is number 8, ladies and gentlemen. And then that brings us to number what? 9. Nine is similar, though. You say, how is that similar? Well, what do you guys have here again? You don't have x. You got 3x. So by now, what do you guys know? We're going to let theta equal 3x. If you do, by doing that quick substitution, we're now in the single angle mode, which we need. Sine theta is 0. I can add 1 to both sides, and now I get sine theta being 1. Somewhere I have that curve. Do you guys know? Maybe we need to bring it out again. Okay. Yeah, it's not perfect, but okay. Positive 1, negative 1. This is a sine curve. 2 pi, pi over 2, 3 pi over 2. This is sine, is that right? So we have the intercepts, maximum value. Then we go, okay, here we go. Not the best picture of sine, but all we need to know, where is sine 1? Pi over 2. So this means theta is simply at pi over 2. There's only one solution from 0 to 2 pi. Is that right? So in general, what does that mean? You're going to have to add what? 2n pi. Okay, there's only one solution. If you wanted to do all students take calculus, I'm going to have to, maybe I can do this. I can copy that. Show you my point here to this. Paste that, but I don't want all this junk. Pi over 2 is what we're referring to. This is the angle right up here. Okay, that's 90-degree angle. Is that right? So there's only one solution. So this is why we say pi over 2 in general. We're going to have to add, to get every coterminal solution, we're going to have to add the 2n pi. N is a what? Integer value. But what was theta to begin with? Oh, here we go. Theta was 3x. Remember, we did that substitution, so we have to replace that theta with what? 3x here. Say, okay, 3x pi over 2 plus what? 2m pi. Now, divide both sides by what? 3, because you got to solve for x. This means x is pi over 2 divided by 3 plus 2n pi divided by 3. This is the only place we could do some simplification. Because pi over 2 divided by 3 is really pi over 2 times what? 1/3, which is pi over 6. So your final answer for x, ladies and gentlemen, becomes pi over 6 plus 2n pi over 3. Okay, n is a what? Integer value. Okay, you guys see this here? That's number 9. And I didn't think we were going to get to number 10, but we did. And there's multiple ways to do number 10. Just going to share with you number 10 here, okay? Multiple ways. Obviously, you start by saying, I have x over 2. Can I call that theta? We'll say yes. So theta is really x over 2 by substitution, which gives me cosine squared theta minus sine squared theta equal to 0. There's multiple ways to do this. Okay? Here's what I'm going to say. I'm going to add sine squared theta to both sides. So we'll get cosine squared theta equals what? Sine squared theta. Or we can say sine squared theta is the same as what? Cosine squared theta. Multiple ways to do this. I can divide both sides now by what? Cosine squared theta. And what do you get now? You get what? Tangent squared theta equals 1. Now, I can say this, ladies and gentlemen. I'm going to say, let T be tangent theta, which means I have what? T squared is 1. So maybe you want to see it that way. So what are you guys going to use here? What do we say? Use the square root what? Formula. So that T will be plus or minus the square root of 1, which means T is plus or minus 1, but it's not T. Okay, it's not T, it's really what? Tangent. Now, I didn't really have to do this. I could have used a square root formula right up in here. You know, and I do that personally. I don't do a substitution, but when you teach this to people, that might be the first place you what? Remind them, because sometimes students need that. So tangent theta is 1, and tangent theta is what? -1. All right. So all of that to get 2 equations again. Okay? All of that work to get 2 equations for number 10. So all you got to do now is remember all students take what? Calculus. Because we have to identify, again, where tangent is positive and where tangent is negative. And if we can make this bigger, that would be helpful. I want to do that. Just want to make it bigger. Because they have to find the quadrants, okay? Do you guys remember that? All right. Tangent is positive in quadrant 1 and quadrant 3. So, ladies and gentlemen, what do you notice about this? Opposite solutions, right? Opposite quadrant solution. Tangent is negative in quadrant 2 and quadrant 4. So you say, I notice again what? The opposite quadrant solution. So I have a solution really in every quadrant. Okay, I want you guys to visualize that. That's an important detail. Visualize that one, ladies and gentlemen. You guys see what I'm saying? And then the quadrant 1, I think we already know, quadrant 1, the reference quadrant. This really means if tangent is 1, theta is pi over 4, ladies and gentlemen. Is that true? So here's what I want to remark. Here's my angle. It's a solution for theta. This is the reference. I'm going to say to you guys, only do what? Only get solutions in quadrant 1 and quadrant 2. What do you guys think? Is that a pretty good idea? Now, why is that? Because there's opposite what? Quadrant solutions. And quadrant 2 we know is what? Not x. Theta is pi minus what? Pi over 4 for the quadrant 2 solution. Don't forget to put 4 pi over 4, which really means the following. This is your quadrant 1 solution. Theta is 3 pi over 4. This is the quadrant what? 2 solution. But to get all coterminal solutions now, we take the pi over 4 in quadrant 1 and add a multiple of n pi, not 2n pi, n pi. We take 3 pi over 4 and add a multiple of n pi as well. And you might say, why would you do that? Because, ladies and gentlemen, what do you guys know? They're in opposite quadrants, both orange and green. So, I mean, this is the approach here, ladies and gentlemen. This is fantastic. It's like we started with this, we end with this. But what is theta? Because don't forget, this was not given in terms of theta. This is given in terms of x over 2. So theta is x over 2. You go, wow, okay. X over 2. X over 2. So, ladies and gentlemen, here you go. You guys ready? X over 2. Pi over 4 plus n pi. X over 2. 3 pi over 4 plus n pi. Don't forget to do what? Multiply 2 to both sides. Cancel, 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 cancel. And then when you distribute, ladies and gentlemen, don't forget, I'm going to give the final answer here, okay? X is going to be, yes, it's 2 pi over 4 on top, but that's pi over 2. And that'll be plus 2n pi. Yes, x will be 3 pi over 4, 6 pi over 4. This becomes 3 pi over 2 plus what? 2n pi. Remember, you're distributing that too. And n is an integer, and maybe we always wanted to write that down, right? And this is saying n is an element of the integers. We talked about that, what the integers were. But ladies and gentlemen, this is how we actually answer this question. This is a general solution here. And again, I think they mentioned, I started to talk a little bit earlier. What about the sequential form? Can you write this as a sequence? Okay, remember that process to write it as a sequence? That's just code for do the arithmetic. I'm going to do the first one there, right? Sequential form. Multiply the top and bottom by that same number 2. You're really going to add here. You get pi over 2 plus 4n pi over 2, ladies and gentlemen. Okay? So you're really adding a fraction with a whole number, and then you're going to recognize an important detail. I'm going to use pink again. I think I did yesterday. See that term pi over 2? See that term pi over 2? You got to factor it out. So now you factor out the pi over 2. This is a nice thing. You end up with 1 plus 4 what? N. N is an integer. This is the sequential form here. It's a nice equation to now generate solutions. You know, just use n is 0, n is 1, n is 2, n is negative 1, n is negative 2. You can generate solutions all day long. This is why this is a very nice way to describe your general solution. And we could do the other one too. 3 pi over 2 plus 2n pi. So you say, what about the other? Well, 3 pi over 2 plus 2n pi. Remember, you're just really doing two things. You're going to add a fraction with a whole number. So you're following that process, and you get 3 pi over 2 plus what? 4n pi over 2. Okay? What you recognize now is simply that multiple of pi over 2, that common factor, because you're really factoring out the common factor of pi over 2. So when you do that, you end up with pi over 2, and then you have 3 plus 4n. N is an integer, And so, ladies and gentlemen, if they ask you, what about your sequential form of these general solutions? Well, you're looking at them right here, okay? Sequential form. And this is a beautiful way to look at things because remember, you say they're all factors or multiples of pi over 2. And how do you get the rest of it? Well, that formula, 1 plus 4n, 3 plus 4n. So just change the values of n. N is 0, n is 1, 2, 3, 4, 5, 6, 7. You get all these solutions here. And, you know, this is, I might even write a worksheet on converting general solutions to sequential form. And we'll see what we do with that. But, you know, ladies and gentlemen, we did get through all 10. So I think I did do your, put your homework. Is that right? You guys remember the assignment? This is a big deal. You guys want to solve these equations here, 7, 5. Let me double check here. Okay, we'll leave it at that. How's that? Okay. So you guys have a wonderful, wonderful Thanksgiving. I thank you guys for being here. You guys are troopers. And, you know, if you need to go to my website, you say, Mr. Judge, I think I need additional help, right? Where could you get the additional help? Remember, you want to use Thanksgiving to do what? To get ahead or catch up. Guess what? I have additional what? Help for you guys right here for some of these. You guys can refer to the what? The resource page. And you could get additional help with some of these things there if this is not enough for you guys, okay? You guys see what I'm saying? All right, you guys, take care, stay safe, have a wonderful Thanksgiving. I'll see you guys on Monday.